All right, students. Good day, everyone. It's Mr. David again, and today I have another video for you on how to follow Blackline proportionally. I actually made this video based on our previous discussion. I gave you some projects and that requires you to follow a black line proportionally, and most of you complain that you don't know how to write a code for that. And I thought it wise to make this video as fast as possible to get to you guys before we meet on Thursday. All right, I hope you will find this video very helpful. I also want to say thank you for most of you that actually appreciated the video I sent previously. And all right, let's get to it. Before we go into serious business today, I want to quickly advise you on something. You see, these videos I've been sending to you guys, all the classes we've been having on this virtual class, I want you guys to take it serious, because for you to compete in an international competition, you need to be very, very good with programming. You need to be very flexible. You need to be very creative. You need to bring in your own creativity into what you are doing. You understand? It's a free ground where you can do a lot of stunts, and there's no limitation. So it's still a bit easy now. We actually started with you guys from scratch, so it's easy for you to understand the basics, but as time goes on, it's going to get complex, it's going to get serious. You understand? So I want you to tag along and make sure you ask necessary questions. Be free to discuss it with us so we can put you through, so that when you get complex, you won't be lost or maybe get discouraged and quit. So go to the flow control, and you see all the blocks under flow control. I need you guys to play around with these blocks. I'm actually making a video for you on this second action, but it's not going to be simple. It's going to be a bit difficult. So I don't want it to be that difficult for you. That's why I'm asking you to do this assignment for me. So I want you guys to just play around with these blocks. Just keep playing. It's not a project. There's no mistake. Just get used to the way these blocks work. You can even go to the internet to or go to Lego sites, to be precise, and search for these blocks and see what you can get on them. The first one is the wait block, then you have the loop block, then you have the switch block, and finally the loop interrupt block. So the first thing you do here is to go straight to the flow control and look for loop block. Here we go. This is the loop block. Bring it out here and drop it on the programming canvas. I'm going to be dropping all the blocks we need before editing them. So the next block you're going to be looking for now is your color sensor block. So you go to sensor, then you look for color sensor block. It's the second block from the left. Then you pick it, you drop it. That's fantastic. So the next block we're going to be looking for here is the mathematics block. We need two of it. So you go to data operations to reveal all the data blocks here. So you just look for mathematics block, and this is it, math block. You pick it, you drop it right inside the loop block. We need another one. You pick it and you drop it right inside the loop block. And finally, the last block, which is going to be from the action block, is a move steering block. So this is the third block from the left. I'm picking it and I'm dropping it right here. So this is fantastic. Okay, let's make it more vivid for everyone to see by zooming in. So I'm going to be zooming in. Okay, then centralize it. So let's go to the pen tool and pick this. So everything is very clear now. I think you can all see this. Don't forget to go to pick to change the hand. So you can just come to this place and just name this block. So I want to call it demo as usual. So demo class. So this is it. This is the title, because you can have series of these in your program line, but this is only one. So in order for you to get it twisted, so if you have series of these in the programming line, this allows you to tag them so that you don't get confused, because they might sometimes look very similar. All right, let's start editing it. So the first thing you do here, this is our color sensor block. is actually on default now, so I don't need to do anything serious here. I will just come to this place and click on it, go to measure, and come to reflected light intensity and click on it. So when I'm done with this, I'll just take the output of this color sensor block and insert it in the input of the first matte block, the A port to be precise. Then come to this place and change the sign to subtraction. And the reason why I'm doing this is because I want my robot to maintain an effective proportional constant while it's running on a black line. The reason why I'm putting this subtraction sign here is for the robot to automatically come to the black line anytime it derails. So I've actually programmed it in a way that when it goes to the left, it means that it's having a negative value to the left, and the proportional constant for this subtraction is actually 0, because once it's on a black line, it's actually 0. So if the robot is derailing, if it's moving to the left side, it's going to be having values like -1, -2, -3, you understand, depend on how far the robot is from the black line. So automatically the robot corrects itself and come back to the target path. So if the robot is going to the left, to the right side, it means that the robot is actually having a value that is more than positive value that is more than 0 to the right side. So automatically there's going to be a kind of subtraction to bring it to 0 so that the robot can come back and follow the target track paths. So that is why I'm changing this to minus. So I can teach you some other operations maybe next time, but for now this is what we need. So let's go to the next action here is for you to change this one to 25. 25 is actually the default for reflected light intensity that I've actually taken from here. Actually, in a real life robot, for you to get your reflected light intensity, you need to hover your robot over a black line so that you can read the reflected light intensity on the LCD screen of your EV3 Mindstorm. But this is a virtual environment. I can't really do that now. So I think I have a preset which works perfectly for me. So all I need to do here, since this is default, I've inputted it. So the next thing I will do here is to take this output of the first matte block and put it directly on the A input of the second matte block, and come to this positive sign and change it to multiplication. And the reason why I have to do this, the reason why I'm using the multiplication sign is for me to maintain an optimum proportionality while I'm following the black line. It has to be accurate. I need to maintain precision. So that's why I'm actually making it a multiplication sign. So what this is actually doing is actually multiplying this my reflected light intensity over and over again for the robot to maintain a precision over the black line. And here under this B port of the second matte block, I'm going to put my proportional constant value here. The proportional constant value varies actually from robot to robot, but I think you don't have to stress yourself that much. You can use the defaults in a virtual environment like this, but if it's a real robot, you have to take the reading, and it varies. It's not the same for robots, for different robots. So for now I'm going to be using the constant, the default that I feel works perfectly. There are so many default input that you can put here, but I think I will have to put 2. So like I'm saying, if you know if 2 doesn't work for you, that simply means that you have to keep trying it. It's a trial and error thing, but I think the value ranges from 10 to -10, so you can just keep trying it. But I hope this one will work pretty well for you, but this is what I'm going to be using. So after doing this, the next thing I might want to do here is to take the output of the second matte block. I'm going to pick the output of the second matte block and connect it to my move steering block that I dropped earlier. And this is getting interesting. So, and you come to this parameter here. I've taught you this before. You just click on it and leave it for on. And When you leave it for on mode, then you come to this place. This is 50. This 50 is actually the speed of the robot. That's the power of the robot. There's something you need to understand here, because even if you get everything right, if you don't get this part right, you're going to be having issues, you understand, getting your robot to follow the black line. So what you're going to be doing here, for me, I think I would like to leave it at maybe something 45 or maybe 43. Let me leave it at 43. The problem here is you can take it, the more you increase the speed positively, the faster your robot will be. And when your robot is fast on the black line, proportionality will be very poor. There's every tendency that your robot might just derail from the black line. So I always advise my students to leave it at 50, 55. At maximally, you can leave it at 50. And if you are moving in negative direction, you put it this way. Like I said before in my previous video, I like typing it because I'm not always accurate with the figure. So I'm going to leave it at 50. 50 is the maximum that I feel is advisable if you don't want your robot to still follow the black line. So this is how it works. And then you come to this side of the loop block. I'm actually out of all the blocks. I'm on the loop block now. Is actually on default unlimited, so it means that the robot will just keep moving and moving and moving and moving and moving without stopping until you come to stop it yourself. So I will just well, I don't have to time it because I don't even know the span of the black line that I'm following, so you can leave it on unlimited. And this is a demo class, so I don't have to stress myself that much. So I think we are all good to go right now. Let me quickly check my program again. If there is anything I'm not getting right, I'll quickly detect it and correct it. So for now, I don't think everything is perfect. Well, if you have a question as regards this, you can just chat me up on the Teams channel, Robotics Teams channel, and I'll be very happy to supply the answers. So for now, guys, it's a very short video. I'm out.